Session 11, A Place for Science in the Catholic Faith. Our opening hymn is God Created Earth and Heaven. God created earth and heaven, God commanded light to be, separated light from darkness, set the bounds of land and sea. While God's Spirit on the waters in his love did gently brood, life on earth began to quicken, and God saw that it was good. God made man in his own image, gave him power to think and choose, made him Lord of all creation, everything is his to use. Let us praise our loving Father, let us thank him as we should, for the gifts of his creation, which his love has made so good. God who filled the earth with beauty, God who built each friend and friend, God made us Creator, God will live at gracious end. Grant to us creative spirits, minds responsive to his mind, thoughts and wills to rule extending, all our acts by love refined. God who gave to life its goodness, God creator of all joy, God who gives us our freedom, God who blesses you and toy. Teach us how to praise and thank you, deep within your praises sing, till the whole creation dances to the music of the King. Isn't it a beautiful hymn?
Yeah.
Really is. In the name of the Father, and of the Son, and of the Holy Spirit.
Amen.
Let us pray. O God, grant us a spirit of wisdom and insight to know you clearly. Enlighten our innermost vision, that we may know the great hope to which you have called us, the wealth of your glorious heritage to be distributed among the members of the Church, and the immeasurable scope of your power in us who believe, through our Lord Jesus Christ, your Son, who lives and reigns with you in the unity of the Holy Spirit, God, forever and ever.
Amen. A reading from the Book of Wisdom. Simply I learned about wisdom, and ungrudgingly do I share. Her riches I do not hide away. Now God grant I speak suitably, and value these endowments at their worth, for he is the guide of wisdom and the director of the wise. For both we and our words are in his hand, as well as all prudence and knowledge of crafts. For he gave me sound knowledge of existing things, that I might know the organization of the universe and the force of its elements, the beginning and the end and the midpoint of times, the changes in the sun of the seasons, cycles of years, positions of the stars, natures of animals, tempers of beasts, powers of the wind and thoughts of men, uses of plants and virtues of roots. Such things as are hidden I learned, and such as are plain, for wisdom, the artificer of all, taught me. For she is the refulgence of eternal light, the spotless mirror of the might of God, the image of his goodness. The word of the Lord.
Thanks be to God. The wisdom literature in Scripture is so beautiful, and it's not just the book of wisdom, but the other wisdom literature as well, giving us insight into God's creation and how good God is, and expressions of that goodness. This week, then, what the church teaches. An atheist, as we mentioned last week, an atheist believes that God does not exist. He explicitly rejects the intimate and vital bond between God and humans. A scientist who studies God's creation need not be an atheist. Both basic scientific research and applied research are expressions of the dominion over creation which God gave Adam and Eve. Science and technology are precious resources when placed at the service of man. However, by themselves, they cannot disclose the meaning of existence or human progress.
So, since we're talking about science today, you may not be too surprised to find a scientific experiment set up. Many people are taken in, Pope John Paul said, by the myth of incompatibility between the spirit of science and its rules of research on the one hand, and the Christian faith on the other. They mistakenly think that he who proceeds with a commitment to scientific research no longer has need of God, and vice versa, that he who wishes to believe in God cannot be a serious scientist, because between science and faith there is an irremediable conflict. No, this is a myth, the Pope said. On the contrary, many scientists, past and present, see rigorously conducted scientific research as not only compatible, but even happily capable of integration with the sincere and joyous recognition of the existence of God. Certainly, the knowledge found in God's revelation and the knowledge found by science are different. For example, compare the Bible story of Adam and Eve with the scientific theory of biological evolution. But before we go any further, compare these two. You don't have this in the print copy. This is something sort of extra. I call it two descriptions. My husband, John Doe, must be the best husband in the world. He often tells me what he likes about me, with concrete, not empty compliments. He even praises me in public. He's the most even-tempered and least easily irritated man. Our few quarrels have arguably been my fault. Even so, he is always willing to say, "I'm sorry and I forgive," almost as soon as a quarrel begins, as St. Paul urged. He never lies. I can always trust his word. I know beyond a shadow of a doubt that when he made his marriage promises, he meant them to bind him in bad times as well as good, and there have been some bad times. In fact, I have never known him break any promise. He always follows through. And if he is ever late, I can be sure that there is a good reason. And he is still a considerate, kind, understanding, and altogether wonderful lover. This is signed Jane Doe. Her description of her husband, John Doe. Now, another. I examined John Doe as a patient at my clinic on September 26, 2000. He was then 52 years old with no concerns about his health and no history of medical problems. He is 180 centimeters tall and weighs 82 kilograms. He does not smoke, use drugs, or drink alcohol to excess. His only exercise is walking to and from his place of work. His blood pressure is 120/75. His resting heart rate is 70. His rate of respiration is 17 breaths per minute. His temperature is 37.0 degrees. There's no sign of irregular heartbeat or heart murmur or osteoporosis or arthritis. Ears, nose, sinuses, eyes, lymph nodes, thyroid, and carotid arteries all appear normal, as do nerves, muscle strength, reflexes, balance, and mental state all appear normal.
Sounds like me.
This is signed by Dr. Which?
All the good things.
Not the wife's description.
No.
This is signed by Dr. James Smith. Now, those two descriptions are as different as the difference between the Bible story of Adam and Eve and the scientific story of biological evolution. People try and decide which of those two is true. Let me ask you, which is the true description of John Doe? The one by his wife or the one by his doctor? Is it necessary to reconcile the two descriptions? Do they contradict each other? Of course not.
In fact, you couldn't even necessarily recognize that they were speaking about the same person.
That's true. The Pope says science and revelation, just like a wife's account and a doctor's account, cannot be opposed to each other, for they both show us truth, and truth cannot contradict truth. If it seems to, we may be sure that some mistake has been made, either in the interpretation of the sacred words or in the discussion surrounding the dispute. And that comes from Pope Leo XIII, back in the 1800s. The explanation is that science and religion represent two different orders of knowledge. They bring out different aspects of reality, just as those two accounts of John Doe bring out different aspects of the truth. It was tragic mutual incomprehension that led to the Church's condemnation of Galileo. To avoid such mistakes in future, both sides must have an informed awareness of the field and of the limits of their own competencies. The wife can't possibly give the description the doctor's done. The doctor can't possibly give the description the wife has given. Each must know the limits of their own competencies. And that's from Pope John Paul. This course, as you must know by now, is about God and how we relate to Him. In this talk, we will see how we relate to God in the human activity we call science.
Couldn't help but thinking, you wouldn't say that somebody who weighs out a pound of potatoes is not religious. You wouldn't say that they're being irreligious because they weigh them, but they're looking at it from a different point of view.
Yeah. So let's start with what scientists do, which we'll actually show you in a minute. Modern scientists restrict their study to what they can observe repeatedly by means of the senses. Then they search their observations for patterns. From babyhood, we all see such patterns. For example, when we push things hard enough, they move. When we stop pushing them, they stop. If we do not support them, they fall. We learn enough of such patterns for us to function in the world. To this extent, we are all scientists. However, real scientists observe more events more accurately and discover deeper, wider, and more detailed patterns. For example, by age 16, students know that things pushed harder speed up more quickly. Many of them have driver's licenses and they know it about their cars. They also know that massive trucks speed up less quickly than cars. But in physics, they perform the experiment we're going to perform to describe these patterns mathematically. Now we have measured the mass of this card. We've weighed it. And I wrote it down. Its mass is 4.133 kilograms. You can see that we've added 3 kilograms to it to make its mass greater. Otherwise, it speeds up too quickly, as you'll see.
10 pounds.
Okay. Scientists have always used kilograms ever since the French Revolution. We've measured the mass of a card. I'm going to pull it with a spring scale, which measures the force. So inside this little device is simply a spring with a hook on it and a scale to say how many newtons of force I'm pulling with. And I've carefully zeroed it so that it reads 0 when I'm not pulling with any force. By the way, we've also leveled, as well as we can, this bench we're working on. Now, to record the speed of the cart as I pull it, we're going to have it pull a paper tape through a vibrator. A vibrator, can you just turn it on so people can hear it vibrating? So it's like an old doorbell or fire bell. It makes a dot on the tape because it strikes the tape through a piece of carbon paper, which makes a dot on the tape every 60th of a second. And it's 1/60th of a second because that is the frequency with which voltage varies in our part of the world. The voltage goes up and down, and it changes every 60th of a second. And in this way, we're going to obtain a record like the one on page 150, if you've downloaded the print copy. We'll try and show it to you, but we may have to describe it because it's pretty hard to see. But the dots will get further and further apart as the cart speeds up. From the spacing of the dots on the tape, students can we're going to calculate, how much speed the cart picks up per second. That is what physicists call its acceleration, A. Now, when I taught this, I used to have every student, sometimes I'd have 2 Physics 11 classes, so I'd have every student in the class do this experiment with a cart of a different mass and with a different amount of force, and tell me how fast his cart speeded up. So on page 151, you can see a table giving the acceleration and the mass and the force that each student used. So let's do that, and then we'll talk about how we find a pattern in this data. So first of all, I have to find out how much force it takes just to keep the cart going at a constant speed, because unfortunately there's friction and other things. So I think I can judge a constant speed, but we're going to run the tape through the timer because that does add a bit of friction. So if you'll turn it on, Father, I'm going to give this a little bit of a push and then try and keep it going at a steady speed. I'll be able to see how steady it was by the spacing of the dots and measure how much force it takes to keep it going. Okay?
Ready?
Yep. Okay. I think, unfortunately, friction is not very constant. It seems to me it was about 1.3 newtons. This is not a very exact experiment. This experiment relies on the number of data points you can get. Can I have a look at the tape, and what would you say? Are the dots sort of more or less evenly spaced?
Yeah.
Which means that the cart was going at a steady speed. So Father's turning the tape over so we can make dots on the other side now.
Yeah, surprisingly even, as far as one can judge.
Yeah. Yep. Okay, so I'll give you the tape. So we'll use the other side of the tape. And this time, I want to see how fast the cart speeds up. So if it took 1.2 newtons of force to keep it going at a steady speed, I'm going to add some force. I'm going to add 1 newton of force. So instead of pulling it with 1.2, is that what I said? Yes. No, I said 1.3. 1.3 newtons of force, I'm going to pull it with 2.3 newtons of force. So that is going to be, it's not an easy thing to do. The cart is going to speed up, so I have to keep the spring ahead of the cart to try and keep the force on it constant. But I've done this, I don't know how many times a year since 1974. So I think I can do it. Let's make sure this is zeroed again. Hook it onto the front of the cart. Now this time,
Just give me a moment.
this time I don't have to give it a push. I'm going to exert more than the 1.3 newtons needed to keep it going. So I'm going to pull it with 2.3. I'm just wondering if I read this properly. I think I did.
Okay.
So 1.3. Okay, so 2.3.
I think we're lined up.
Okay, so Father turns it on. I'm just going to try and keep my eye on here and move my right hand so that the tension in the spring stays constant. Okay?
Okay.
Yep. Now, if you
looked
do...
good, by the way. The acceleration looked good. Looked as
How
if
could you tell?
Just, it seemed as if you were pulling very evenly.
Now, I pulled it for more than a second, so I've got a terrific number of dots. Every 6 dots represents a tenth of a second, and it's very easy to work in tenths. So if you have the print copy, you can see on page 150, you can see marked every tenth of a second. So there's 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
By the way, this photograph in the binder, in the program, you'll see as a photograph of Maureen. The difference is the color of the hair.
Mind you, it was never quite that dark.
I took this photograph back in about 1985 or 86, 87, somewhere there, as you were doing it in your lab at school.
Okay, that's probably enough. Now, we have already prepared a piece of graph paper. Can you hand it to me, Father? Thank you. And along here, we've got 0. This is time. Tenth of a second, 2 tenths, 3 tenths, 4 tenths, 5 tenths, etc. And up here, we've got the speed. 5 centimeters per second, 10 centimeters, 15, 20, 25, 30. So as soon as I get past 30, it'll go off the page and we'll stop recording. So, are you ready, Father?
I am, yes.
At 1/10 of a second, it was 5. The speed was 5 centimeters per second.
Okay.
Tell me when you're ready.
Ready?
The next one was 6.
5, 6.
The next one was 6.5.
6.5.
The next one was 7.
Sorry, just a second. 5, 6. 7?
Mm-hmm.
Sorry. I'm sorry. 5.
Just got 4 spaces from the 5.
Yeah. 1, 2, 3, 4, 5, 6, 7. Wish these were a little bit harder, easier to see. Thank you.
Can you pass it to me? Just want to make sure. Yeah, that's 7. No, that's... Okay, you're too high. 5, 6, 7. Okay?
Okay, 6 right then?
And 6 was right.
Okay.
Okay. Actually, it was 6.5, but that's good enough. Okay. So 5, 6, 7, 8, 9, 10. I gave you 9, didn't I?
No, 7.
Okay, we'll have to go back to the beginning. Sorry.
5.
5, 6.
6.
6.5, I think I said, or
Yes.
6.
You said 6.5. Okay.
All right.
Okay.
7.7.
7. Okay.
Okay. The next one is 9.
9.
Say when.
Yeah, when?
The next one is 11.
11. Okay.
The next one is 13.
Okay.
The next one is 16.
Mm-hmm.
17. So this is
Hang on
the
a second.
speed of the cart in centimeters per second.
I can't read this. It's just not clear enough. Okay. Okay.
The next one is 19. No, 18, sorry. So I'm measuring the distance the cart went in 0.2 of a second and dividing by 2. Okay?
Mm-hmm.
The next one is 21.
Okay.
The next one is 24.
Mm-hmm.
The next one is 26.
Okay.
The next one is 28.
Mm-hmm.
The next one is 32. Is that going off the
No.
page? No?
Still got one more, I think.
32. The next one is, 37. No, sorry, that's not right. 34, sorry.
Okay.
And the next one
That'll be off the page.
Next one's off the page?
Yeah.
All right, so let's stop there. We've probably got enough data. What a real scientist would do is do this experiment many times and average his results. So if you'll pass me the graph, I'll do the calculations that we need. Okay, so I pulled it a little bit too low at the beginning. When I look at the graph, it's kind of going up like this.
You weren't pulling hard enough?
I guess so. So I'm going to kind of, I think I was pulling the right amount. I'll just kind of average it so that every point is pretty close. And we'll see what we get. Now, if that represents a sort of average, then the cart speeded up from there to there. The cart speeded up. The cart speeded up 23 centimeters per second. So it speeded up by 23 centimeters per second in 1 second. So I'm going to write that down. 23 centimeters per second per second. Now, with that, what I would get the students to do on page 151 is to say, all right, so I would add a line to that table. When the force doing the speeding up is 1 Newton, and the mass was 4.13 kilograms. The acceleration I got was, now I want to put it in meters per second, so that'll be 0.23 meters per second. And now it was Isaac Newton who discovered that this 0.23 meters per second was related to the ratio of the force to the mass. So I'm going to take a calculator and take the 1 Newton of force and divide it by 4.133 kilograms, and I get 0.24. So in the last column, the ratio of the force to the mass is 0.24. Now I'm going to see how it fits into the pattern that you can see on the graph. So I'm going to go over along the x-axis to 0.24, as near as I can judge it. And the acceleration was 0.23, as near as I can judge it. And if you won't be able to see that, unfortunately, but if you've got the print copy, you can see that that data fits on the same graph that the other points fit on. Not exactly, because no measurement is ever exact, but near enough to show you that there is indeed a pattern.
Also, in your position of pulling it like this, sitting on the Chesterfield, is very difficult.
If anybody wants to see the experiment done better, come to one of our in-person sessions, either at John Paul II Pastoral Centre on Sunday afternoon, or the St. Anthony's in West Vancouver at 10 a.m. on Monday, where I'll be doing it standing up and probably do a much better job.
With a better table and everything, it'll be easier.
You can also see exactly what the graph looks like, which I can't let you see here, and see the calculations. But a pattern. This isn't a pattern students could find on their own. They need guidance from the teacher. But they can see that the teacher is using their data that they have observed, and that there is a pattern in their data.
And this is consistent with our experience. When you put your foot on the gas, if you leave your foot at a constant position on a level piece of ground, you find the acceleration.
Well,
to a
that's
certain,
a bit more complicated because the friction changes with the speed of the engine.
Yes, but I mean, for certain, within certain limits,
within
you get
certain
a pretty
limits.
good, yes.
Yeah. As we said at the beginning, students already know more force, greater acceleration, more mass, lower acceleration. Now they're doing it mathematically. So, this is the pattern the students find, guided by the teacher. They see the pattern first observed by Isaac Newton. Now, if you do have the print copy, or if you do come in person, you'll see that the angle of that graph is almost showing that the acceleration is equal to F over m. Pretty hard to see. The acceleration is equal to F over m, or as it's usually written, F equals ma. And if you did take physics in school, you must recognize that. One of the most important, one of the most useful relationships in physics.
So we don't need any of this anymore, do we? Shall I move it off?
You can move it off if you like, yeah.
Yeah.
So that's what scientists do. They observe, they take measurements, they look for patterns, and they find them. Now, let's talk about finding patterns. I love, in a poem I'm very fond of, the universe is crazier and more of it than we think, incorrigibly plural. Not even two electrons are identical, for at any given moment they occupy different positions. In fact, every real thing or event in the universe, including its place and its time, is absolutely unique. But for scientists to find patterns in what they observe, they must look for similarity and repetition. That is what pattern means. Accordingly, when scientists observe a thing or an event, they deliberately ignore everything that makes it unique. For example, this experiment took place at my address at 3:05 in the afternoon. That makes it unique. For example, when I taught students how to analyze motion on a slope, I would start by drawing a skier on a ski run. Not that I'm much of an artist, but enough to make them see what I was talking about. Then I would reduce the skier to a small dot and label it with his mass. One year, a student said humorously, "Poor guy, how would you like to be reduced to a dot with nothing but a mass?" The joke made the class realize that we could not describe motion on a slope in general unless we ignored everything that made our skier unique. The date, the time, the place, his name, his health, the color of his hair, etc. In fact, everything that made him concrete and historical. Similarly, to find patterns in the motion of the planets, Johannes Kepler ignored their names, sizes, colors, atmospheres, temperatures, etc. But when we observe Venus, Mars, and Jupiter in the night sky, we do not see the patterns Kepler found. Instead, and I'm quoting the same poem, we feel the drunkenness of things being various. We see each planet festooned with those particularities in which science as such has no interest, and therefore, for her own purposes, quite rightly discounts. To see Kepler's patterns, we have to go to his work. Father has a rather amusing habit of, if he does say something which I, as a physics teacher, say no. In fact, I was sort of saying that when Father said about a car. But Father will say, "Well, how do you know that?" And I say, "By experiment. We did that experiment in my class last Wednesday." "Ah, but that was last Wednesday. Today is not Wednesday." Actually, it is, isn't it? I chose a bad day. But, he's doing it as a joke. He's quite right. But we have to ignore the time. Otherwise, science falls apart. If every event is unique, we can't find patterns. Pattern, or order, does not display itself of itself. If it can be said to be there at all, it is not there for the mere looking. There is no way of pointing a finger or a camera at it. Order must be discovered, and in a deep sense it must be created. We'll come back to that point. What we see as we see it is mere disorder. I remember saying to a man many years ago now, he said, "The incredible order in the solar system." I said, "Yes, but you only see that order if you ignore what makes every planet unique." He said, "Oh, I never thought of that." In summary, scientists observe the physical universe and look for patterns in their observations. Now let's consider what God does. God is the Lord of the universe, whose order he established and which remains wholly subject to him, completely subject to him, and at his disposal. To the things he creates, angels, humans, animals, plants, planets, rocks, molecules, atoms, he not only gives being and existence, but also, and at every moment, upholds and sustains them in being, enables them to act, and brings them to their final end. Accordingly, we must imagine God running the universe by a continuous, ongoing decision. It is not a toy, like a toy that he winds up and then leaves to run on its own. And that often surprises people. That is the heresy of deism, which was condemned by Pope Pius IX back in 1864 and 1862, again condemned in the Catechism, again stated by Cardinal Joseph Ratzinger, later Pope Benedict XVI, in his book, Where is God? The universe is not like a toy that God winds up and then leaves to run on its own. It's more like a game of solitaire, which requires his constant attention. Now, I'd like to continue that analogy. A game of solitaire, which requires God's constant attention. Now, of course, whenever we talk about God, we use time words like constant, ongoing decision. For God, of course, it's one creative act. But to continue this analogy, imagine two-dimensional creatures. I've got some here. Little white two-dimensional creatures. I got them out of my punch. Okay? Their universe is the surface of a card table. On this table, Father Vince is playing solitaire. Now the creatures, being two-dimensional, can see the cards on the table, but they cannot see the player, for they are incapable of perceiving dimensions outside their universe. Now, if these creatures observe the cards on the table, they will notice patterns in their behavior, because Father is playing the game called solitaire. For example, they will notice that cards of the same suit, diamonds, hearts, clubs, and spades, pile up on top of one another in sequence from ace to king. Have I got that right? I don't play solitaire.
Yes, eventually, yes. Mm-hmm.
If these little creatures observe the cards long enough, they will learn what are called the rules of solitaire. Now we, who are not confined to the surface of the table, can see the player. We can see that it is he who determines everything on the table. Not one card falling to the table without his purpose and knowledge. We can see how foolish the two-dimensional creatures on the card table would be to declare that there is no player, but that cards play themselves, or that cards know the rules, so that a 4 on top of a pile is caused by the 3 below it, or that the rules are unchangeable based on the nature of the cards. No, Father is playing this game, but it has a pattern in it, or many patterns. Think of God as the player and the universe as his card table. We who inhabit the universe can observe what happens there, but we cannot see God. Nevertheless, it is he who determines everything. The Bible, Catechism says, affirms God's absolute sovereignty over the course of events. His care for the world, what we call his providence, is concrete, that is real, not imaginary, and immediate, that is direct, without anything between. Therefore, if my cart, the one I was pulling, in my lab, in my lounge, on the day I perform the experiment, speeds up at a certain rate when I exert a certain force on it, it's because God makes that card at that time accelerate at that rate. F equals ma, then, which comes from that graph, comes from what we observe, is our description of a pattern in what God normally does. F equals ma, that graph, is our description of a pattern in what God normally does. Now we say normally because God does not have to stick to the patterns we find. Father doesn't have to stick to the...
I did something mistake. Okay, never mind.
Okay, he's done something different without meaning to.
No, I accidentally picked up 2 cards.
Oh, all right. God doesn't have to stick to the patterns we find. He sometimes does something quite unusual or even unique. We call it a miracle. Something that, like everything else, is wrought by divine power, but apart from the order usually observed in nature. That's how St. Thomas Aquinas defined it. Everything happens by God's power, but but sometimes it happens outside the pattern. For example, well, I won't give an example right now. However, God is not capricious. He does have normal or usual ways of doing things. His creation is ordered. He has arranged all things by measure and number and weight. In practice, then, his creation is predictable. For example, scientists can use the pattern F equals ma to predict the motions of galaxies, stars, planets, space vehicles, satellites, and cars. And the police do use that law. On one occasion, I was teaching one of the consequences of Newton's pattern, and I looked up to see two RCMP officers watching me through the open door of my classroom. So I went to see what they wanted, and one of them had been a student of mine. So I pointed to what was on the board, and I said, "Do you remember any of this?" He said, "Nope." Excuse me. The other one said, "I do. I studied it at university." I said, "Do you ever use it in your job?" He said, "No, but there's a guy down at the station who does." Excuse me. And he told me that after an accident, if the first policeman on the scene cannot see exactly what happens, he calls in this particular guy who takes measurements and then uses the pattern, F equals ma, excuse me, and consequences of it to determine what happened.
Including the weight of the vehicle and the road conditions.
They actually came to my class a few weeks later and gave us lots of examples. In fact, in order to do science at all, scientists must assume that their patterns apply always and everywhere. You can confidently predict that if you want your car to accelerate, excuse me, you must exert a force on it. Force is not logically necessary, in the sense that God could not possibly make the car accelerate. Excuse me. Force is not logically necessary in the sense that God could not possibly make the car accelerate otherwise, but it is necessary in practice. Accordingly, even though we know that God causes everything, we say that force causes acceleration. We call God the principal cause and force, excuse me, the secondary cause. Because God is the first cause of all that is and all that happens, the Bible often attributes actions to him without mentioning any secondary cause. This is not a primitive mode of speech, but a profound way of recalling God's primacy and absolute lordship over history and the world. For example, we read in the Bible that God dismisses the light and it departs. He calls it and it obeys him trembling. He tells the numbers of the stars. He calls each by name. When he calls them, they answer, "Here we are," shining with joy for their Maker. Nevertheless, God normally operates in and through secondary causes. Now, once a pattern, like the one we saw in that graph, is generally accepted, scientists often call it a theory. The word does not, as many people think, denote uncertainty, but suggests a pattern as distinct from an observation. Scientists may also call the pattern a law. Instead of saying that an object behaves according to the pattern F equals ma, they say that it obeys Newton's law. Unfortunately, law and obey imply that F equals ma is a rule that commands objects to behave in a certain way.
Made by Newton.
Just as the Ten Commandments or the laws of the land command humans. I remember a student once who'd come from a country where I guess they didn't do any labs. So he didn't know where, for example, F equals ma had come from. He didn't realize it had come from observation and measurement by us. And we were doing a similar experiment. He said, what are we doing this for? Don't we know the result? I said, well, I do because I've done it before. Do you? He said, it's a law. And I said, and where did that law come from? It's a law. That's the trouble with that word, and you'll notice that I try not to use it. No, the laws, as so-called, of science do not make things happen. They are simply the patterns we find in what God normally does. And to make the point that these are our patterns, the patterns we find, let's just look into how these patterns can be changed or even abandoned. F equals ma has not been abandoned. We still teach it in school and use it to predict the motion of what we call normal objects. However, in the late 1800s, scientists observed that objects with speeds near the speed of light do not fit this pattern. In 1905, in order to include these fast objects, Albert Einstein published a deeper, wider pattern we call special relativity. Also, about the same time, scientists discovered particles so small that the very act of observing them changed their behavior unpredictably. For example, in order to measure a particle's position, you have to shine light on it. Unfortunately, the impact of even a single photon of light changes the particle's speed. In fact, the more accurately you measure its position, the less certain you can be of its speed, and vice versa. No improvement in measuring techniques can ever reduce this uncertainty as far as we know. It seems to be fundamental to our observation of small particles, and therefore fundamental to any pattern we find in their behavior. Accordingly, scientists came up with a new pattern we call quantum mechanics. F equals ma predicts exactly how fast an object will accelerate. But quantum mechanics predicts only the probability that a particle has a speed or a position between given limits. For example, the probability that its speed is between 2,99790 kilometers per second and 2,99791 kilometers per second. Similarly, in cribbage, you cannot predict exactly what cards you will get, but only the probability that you will get a particular hand. For example, from a deck of 52 cards, you can get 20,358,520 different combinations of 6 cards. So we say that the probability of getting any particular combination is 1 out of 20,358,520, which, if you're interested, is 0.000049%.
Which, when you're playing cards, you don't usually try to work out quite as accurately.
No, but a good card player has a good sense of the probability.
Yeah. So
in summary, scientific patterns change to accommodate new observations. But, and some people who think that science gives us absolute truth, absolute unchangeable truth, don't like this point, but it's the truth. Science, the patterns that we discover in God's creation are also changed or abandoned according to fashion. For example, in 1597, Kepler found and published a pattern which, with linked the 5 spaces separating the 6 known planets to the 5 geometric solids that could be made from identical regular polygons. I'll just show you a picture of that. This is pretty big, so you can probably see it. Each of those shapes is made of polygons, that is, many-sided figures, which have, like the one near my hand here, it's made of pentagons. Each side of that solid has each side of it, yes, has 5 sides. The one below, this one, has how many? 1, 2, 3 in each side.
Triangles.
This one is one we're very familiar with, a cube made of 6 squares, a tetrahedron made of 4 triangles. And I've forgotten what they call this one, which is the most complicated. But there are only 5 that you can make out of polygons that have identical sides. The ancient Greeks knew that. Kepler, struck by the coincidence of 6 known planets and therefore 5 spaces, somehow, this is the best picture I have of it, he somehow took those shapes and fitted them into each other in such a way that the distances between them, I don't know quite how it worked, actually were very close to the spacing between the planets. And this was considered such a discovery that as a result, he was invited to assist the astronomer Tycho Brahe at Prague's new observatory. When Brahe died, Kepler inherited his extremely accurate, decades-long records of the planets' positions in the night sky. It's worth reading about if you're interested. It was my favorite topic to teach in Physics 12. Apparently, for decades, he simply recorded how far above the horizon various planets were.
It's so accurate.
Very, very accurate. He built a huge protractor. He even allowed for the effect of the atmosphere on the light coming from these stars and planets. Amazing. Anyway, Kepler inherited. Apparently, Brahe didn't look for patterns, he just made observations. Kepler was the one who started looking for patterns. Like all his predecessors, Kepler thought in terms of circles, the perfect figure, which surely, everybody had argued, God would have used. At one point, Kepler discovered a pattern based on circles that described Mars's motion to within 13/100ths of a degree. But he rejected it because he knew that Brahe's observations were rarely wrong by even as much as 3/100ths of a degree. Over the next decade, Kepler found 3 more patterns. You don't have to know what these are, but I'm amazed that anybody ever found them. First of all, he found that each planet orbits the sun not in a circle with the sun at the center, but in an ellipse, which is a flattened circle, with the sun just off-center. If you look at a circle, like this is a bowl, if you look at the outside of it straight on, it's a circle. But if you start looking at it, I don't know which is the best way to tilt it, if you start looking at it sideways on, then it's a flattened circle, not as big this way as this way.
So perfect circle.
Yeah, that's better. Now you have an ellipse. Now the orbits of the planets around the sun are very, very close to being circles.
Slightly off.
But Brahe had taken such accurate measurements that Kepler was able to show that Mars's motion around the sun was not a circle, but an ellipse, with the sun a little bit off-center. Second, he found that as it moves, each planet changes speed, so that the line joining it to the sun, the imaginary line, of course, joining it to the sun, sweeps out area at a constant rate. So if you can imagine a very elliptical orbit with the sun at one focus, as a planet approaches the sun, it speeds up. So that suppose it takes a day to go from there to there, then this area is the area swept out. At the other end, it's going more slowly, but the area swept out in one day is the same.
Useless, as far as I'm concerned, but incredible.
Not at all useless, actually, as I'll mention in a minute. And third, he found that if you take the planet's average distance from the sun, if it doesn't have a constant distance from the sun, and you multiply by itself twice, so that you have the cube of its average distance from the sun, and that is directly proportional to the square of the time it takes to go around the planet, the sun. The cube of its average distance from the sun divided by the square of its year is the same for every planet. Kepler himself was amazed. He said, when he published this, "I had, by unceasing toil, through a long period of time, using the observations of Breha, I had overcome by storm the shadows of my mind. With such fullness of agreement between my 17 years of labor on the observations of Breha and this present study, that at first I believed I was dreaming." Amazing. These last three patterns have endured. We still use them. They describe even modern spacecraft, which, during their journeys to other planets, we try to send them taking as little energy as possible, during their journeys to other planets, they orbit the sun like the planets, and they fit the same pattern, these three patterns that Kepler found. But scientists have abandoned Kepler's geometric pattern, the one I was showing you, not just because they discovered new planets, but also because fashions changed. This is a beautiful piece of work. We've abandoned it, but not just because we discovered new planets, so there are no longer just 5, but also because fashions changed. Scientists today would never expect a connection between the planets and the geometric solids, nor would they search for a pattern based on what they thought God would have done. It's a different era. Scientists accept. Now, some people use the word believe, but that is not appropriate for scientific patterns. You don't believe a pattern, you accept it. Scientists accept a pattern as long as it continues to fit all their observations and to be the simplest and the most appealing they can think of. However, as we have seen, these patterns or theories can change.
It's interesting, by the way. I don't know about you, but sometimes I go into a room and I'll look at the tiles on the floor, and you'll realize that there's a pattern in the manufacturing, or ceiling tiles, or bathroom tiles. Sometimes you look at it, yeah. And I've noticed in my bathroom, for instance, there's a pattern of mostly irregularities in the casting.
But I'm sure on another occasion you'll see a different pattern.
Yeah.
So if scientific patterns, if the patterns scientists see in what God does, change with new observations or with fashion, is there ever a point at which a scientific theory can be considered proved in the way people would like? The answer is yes, but only in the sense that we consider our everyday beliefs to be proved. That is, they will do to be going on with. They are good enough to act on. Anyone who waits for a scientific theory to be proved in any more rigorous sense will wait forever. To sum up then, God is the first cause of everything, but normally he operates in and through secondary causes. That is, he operates in predictable ways. Whenever you see a force acting on something, the object speeds up or slows down. I've never seen it fail, but it could. The business of science is to discover and describe the ways in which God operates. For example, Breha observed the solar system. Kepler found patterns in Breha's observations. Newton accounted for these patterns with his so-called law of universal gravitation. He discovered a deeper pattern, not just these are kind of neat patterns, but oh, here's why. Sailors observed the fit between the coasts of Africa and South America when they began to map the shores of the Atlantic about 400 years ago. I'm sure any child who's colored maps in school has noticed how Africa fits into South America, or rather, perhaps the other way around. In 1812, Alfred Wegener accounted for this fit by his theory of continental drift, suggesting that South America and Africa had once been joined. Another example, in 1848, physicist Hippolyte Fizeau observed that the spectra of stars match spectra on Earth, but are shifted toward the red. Now, the spectrum, have you got that crystal or have I got it? You got it. You've all seen, we call them normally rainbows, caused by crystals like this many-sided crystal. Scientists call them spectra, and the colors in the spectrum go all the way from red to violet. And if you shine light through all sorts of different materials, you see slightly different spectra. Scientists can often identify an element by its spectrum when they put light through it. Now, what this physicist noticed was that the spectra, the patterns in the spectra, match spectra on Earth, but they're all shifted toward the red end of the spectrum. Fizeau accounted for this shift by suggesting that all the stars are moving away from us, as if the universe is expanding. In 1931, Georges Lemaitre, who by the way was a Catholic priest, accounted for this expansion by suggesting that the universe had undergone, not started with, but undergone a Big Bang.
Something had exploded.
From Aristotle on, biologists observed physical and genetic similarities among species. In 1859, Charles Darwin accounted for them by his theory of biological evolution, which asserts that all species had a common ancestor. So I tried to get an example from each scientific discipline. Do we have to account for our observations and patterns like this? Can we not just say, that's the way God made things? We can do either or both. And this is connected to what we talked about at the beginning, that science and religion are talking about different orders of knowledge. And C.S. Lewis has what I think is a remarkably good analogy. He says in Shakespeare's play, Hamlet, Ophelia, driven out of her mind by Hamlet's rejection, climbs onto the branch of a tree overhanging a stream. The branch breaks, she falls into the water, and eventually she drowns. We can account for her death by saying either Shakespeare wanted her to die, that would be the primary cause, or the branch broke, that would be the secondary cause. The two accounts are different, but you can see that they are both true once you realize that Shakespeare made the whole play. Different species have remarkable similarities. We can account for them by saying either God made them similar, primary cause, or they evolved from the same ancestor, secondary cause. The two accounts are different, but they are both true once you realize that God is Lord of the universe and master of history. So in the card game we were talking about, why did that 4 come on top of that 3? You could say because Father put it that way, or you could say because that's the rules of the game.
Both would be true.
Both would be true. Therefore, if we account for the patterns in what we observe by saying simply that God is responsible, we do not make a mistake. However, we opt out of science. As Father George Coyne, S.J., former director of the Vatican Astronomical Observatory, put it. He was giving a talk in mission at the Abbey. Of course, God is responsible for everything that happens, but I don't accept that answer. I'm a scientist. In other words, he believes in God as the primary cause. I'm sure he does as a Catholic priest. But as a scientist, he looks for secondary causes.
If a policeman came up to me and said, "Why were you speeding?" Well, God made me do it.
No.
In a sense, it's true. God made me. I did it.
Well, when it comes to humans, it's a bit different because he has given us free will. Yeah. Similarly, when I asked my students why a cart accelerated, I wanted them to analyze the forces on it. I did not want them to say, God made it accelerate. This topic came up once in I think the last physics 12 class I taught before I retired. And on the next test, one of my students couldn't solve one of the more difficult questions. And so he put on it, he said, I really don't know what the answer to this question is, but whatever it is, it's God's will. So I put a big tick through it and then put a 0 at the bottom of the page. Absolutely correct, but not worth any marks in science. Now, if you followed all this, let's consider some common questions. If God rules everything, how can we speak of chance or coincidence? Now, this is a big question, but very often the people asking it don't really know what scientists mean by chance. To see what chance and coincidence mean, consider the following. Julie walks on the seawall every day at the same time. One day she meets Bob. Julie went for a walk without any plan, design, or expectation of meeting Bob. She then says that the meeting happened by chance. However, without Julie's knowledge, Bob had planned it. He fully expected to meet her. He then says that the meeting happened on purpose or by design. Now, Julie will continue to speak of chance or coincidence as long as she remains ignorant of Bob's design. Once she becomes aware of it, she will stop.
They'll say, what a strange coincidence.
She'll stop saying that.
Yeah.
Okay. In summary, we speak of chance or coincidence insofar as we are ignorant of any purpose, design, or plan. Now, God created the universe by design, on purpose, with a certain plan. His purpose is to make room for created persons in the communion of the uncreated persons of the Blessed Trinity through adoptive participation in Christ. That's something we'll talk about later. His plan, so that was his purpose. His plan is to bring all things in the heavens and on earth into one under Christ's headship. His design will reach its perfection at the end of time, when the universe will be renewed and perfectly re-established in Christ. In the meantime, as God carries out his plan, the universe remains in a state of journeying toward its ultimate perfection. We call the dispositions by which God guides his creation toward this perfection divine providence. And you can see the connection with the word provide. By his providence, God protects and governs what he has made. Everything is open and laid bare to his eyes, even those things which, from our point of view, are yet to come into existence. It is God who, at every moment, does everything, and he does it on purpose, by design. Whatever happens is part of his plan, for he is its sovereign master. However, to us, the ways of his providence are often unknown. Only at the end, when our partial knowledge ceases and we see God face to face, will we see fully how he has guided his creation to the end for which he created it. Until then, as long as we remain ignorant of the mysterious ways of God's almighty power, it is not wrong for us to say that an event has occurred by chance, provided we mean simply that because of our ignorance of God's design, however far that ignorance goes, we could not have predicted it. Similarly, since the characters in Hamlet are completely ignorant of Shakespeare's design, they may rightly say that Ophelia drowned by chance, meaning that they could not have predicted that the branch would break. So, chance is not an agent alternative to God. Chance, when we use probability or chance, we're trying to give words to our own ignorance. Next question. Some people say that the complex yet ordered universe could not have developed by chance. It must be by God's design. Is this reasoning sound? No. To see this, take an easier problem first. Suppose I tell you that I picked 6 cards from the top of a shuffled deck and got 9, 10, Jack, Queen, and Ace of Spades. And for those who don't play cards, that's the order. I can see it's not happening. But suppose I tell you that it did, and it could have. You might very well say that couldn't have happened by chance. Now, if you properly understand chance, you mean that before I picked the cards, the probability that I would get that combination was so low that for me to get it, someone had to stack the deck. However, as we have seen, the probability of getting any particular hand of 6 cards is equally low. 1 out of 20,358,520. And clearly, the lowness of that probability does not mean that the deck always has to be stacked for me to get that hand. Whatever hand I get, and I'm talking about picking 6 cards because cribbage is the only card game I really play, and that's how many cards you are dealt. No matter what those 6 cards are, before they were dealt, the probability of getting that particular hand was 1 out of 20 million.
With those particular suits.
With those particular cards,
yeah.
The only way to find out whether the deck has been stacked is to ask the people who could have stacked it. Now, to estimate the probability that the universe would develop to its present state, scientists imagine that, let's say, n different universes could have developed. On pretty shaky grounds there because there's so many variables, but anyway. Therefore, before the universe started to develop, the probability of its reaching its present state could be said to be 1 out of n. Because n is so great, 1 out of n is very low. However, as in choosing cards, the lowness of this probability does not prove that the universe has to have developed by anyone's design. To find out whether it has, we must ask the only person who could have designed it. And in the book of Genesis, he answers yes. And Pope John Paul said on a number of occasions, that was the purpose of the author of the book of Genesis. To say, yes, God had made it by design, on purpose, with a plan. That was his only motive for writing what he did. People say that Newtonian physics, based on F equals ma, leaves no room for God to act, because it predicts exactly what will happen, while quantum mechanics does. Does that make sense? No. Once again, we must realize that God has absolute sovereignty over the course of events. The solicitude of divine providence is concrete and immediate. It is God who determines everything in the physical universe, like the player who determines everything on the card table. Neither Newtonian physics nor quantum mechanics is anything more than a pattern we perceive in the cards God plays. We think of these patterns as laws that constrain God. Sorry, let me say that again. To think of these patterns as laws that constrain God is to think like the foolish creatures on the card table, who may admit that the player made the laws, but think that from then on, the laws actually cause the game, operating independently of the player. Accordingly, these people wrongly claim, the technical word for people who believe that is deists. They believe that God created, but then stepped aside and let everything go on its own. The church calls that a heresy. These people wrongly claim that Newtonian physics, because it predicts exactly how fast an object will accelerate, forces God, the player, completely out of the picture. While quantum physics, because it predicts only probabilities, leaves him room to determine the exact details. Again, they're putting God on the level of our patterns, whereas two different orders of knowledge.
I often think that on wallpaper, you have a pattern, you see it perhaps for 20 feet along a wall. It doesn't mean to say the 21st foot is going to follow the same pattern.
No.
They could put a different piece of wallpaper there.
Oh, yeah.
Yeah.
No, that is ridiculous. That is to reduce God to the status of one of his own patterns. It's ridiculous. As universal transcendent cause transcending on a different level, God is not only the cause of existence, but also the cause of secondary causes. In other words, the cause of the patterns. His action does not displace or supplant the secondary causes, but enables them to act according to their natures, and nonetheless to bring about the end he intends, although we have no way of understanding precisely how this is possible. Difficult point, but I've heard ever since I was in high school, I've heard, oh, quantum mechanics allows God back into the picture. Well, the God it allows back into the picture is a pretty poor God, not the God I believe in. Next question. Did God create humans, or did they evolve by chance? God created humans, like everything else, by his design. He said, "Let us make man in our image, after our likeness," and that is what he did. Now, this likeness to God, which is what distinguished Adam and Eve from the animals, was spiritual, chiefly in their souls. It could not be observed or described scientifically. I can imagine God creating Adam and Eve out of existing material, whatever it was. Before the change, it was simply that material. After the change, I'm sure it looked exactly the same. The Bible says nothing to make us think that there would be any change in the appearance. But now they had spiritual capabilities that they hadn't had before. They could not be observed.
Look at the difference between the Eucharist. It looks the same
Yeah.
after consecration.
Yeah. So that is what made Adam and Eve different from the animals. Characteristics which could not be observed. However, their bodies could. The question of how God made the first human beings, bodies I should say, is a scientific question. Did he make them out of nothing, the clay of the ground, or pre-existing living things? And again, to quote Pope John Paul, it was not the purpose of the author of the book of Genesis to answer those questions. According to the theory of biological evolution, held sea animals, through those of dinosaurs, to those of the great apes, and thence to those of humans. According to this theory, then, the bodies of the first humans were like those of apes. However, human bodies have continued to evolve, producing the present rich variety of persons, cultures, and peoples. And clearly, if all the people on Earth came from the same two ancestors, which even scientists claim, evolution has continued to make changes. We don't all look alike.
Don't even look like our parents.
No.
Or maybe similarities, but tremendous differences.
The theory of biological evolution must be judged on scientific grounds. Does it account for all the evidence? Is it the simplest we can think of? Pope John Paul II said it must be recognized as more than a hypothesis, but not pushed past the limits of science. More recently, the Church has called it practically certain. And you can look up the documents we've quoted here in the footnotes. The next question. The Church quoted the Bible against Galileo. Can we quote it against evolution? No. On October 31st, 1992, Pope John Paul II formally acknowledged that the Church had made a mistake in condemning Galileo. The Bible speaks to us of the origin of the universe and its makeup, not in order to provide us with a scientific treatise, but in order to state the correct relationships of man with God and with the universe. Any other teaching about the origin and makeup of the universe is alien to the intentions of the Bible. The Bible does not concern itself with the details of the physical world, the understanding of which is the competence of human experience and reasoning. And I think you could apply that question to the short two descriptions of a man, John Doe, that I read at the beginning. The first description was not concerning itself with the physical details of his health and so on, his height and his weight and so on. The understanding of those is the competence of medical doctors. The two people describing John Doe had very different intentions in mind.
Both were correct. Yeah.
The next question, who cures people? God, nature, or doctors? God does everything. We have to keep saying that. It happened naturally means that God did it in his usual ways. The doctors did it means that they cooperated with God. Usually, however, when people ask that question, they mean, was the cure natural or miraculous? If enough similar cures have been observed, this is one of God's normal ways of curing people, so we call it natural. If not, God has done it in a different way, an unusual way, so we call it a miracle. But in either case, it is God who has done it.
It's interesting, often you hear, well, it's Mother Nature, and I think people sort of want to give a name, or not only a name, but also a persona, yeah. And also, well, the weatherman calls for such and such. As if, because you've heard it on CBC, it must be true.
Yeah, God's got to conform. Yeah. Yes. Yeah, he's telling God what the weather's supposed to be. I know. What was the first thing you said? It just reminded me of something.
Mother Nature.
Oh, Mother Nature. Yes, people like to personify, that's the proper word. The same with Lady Luck.
Yes.
Or the goddess Fortuna. You know, people have thought of these as almost persons, alternative to God. Next question, if science is good, why does the Church condemn genetic engineering? Catechism says that science and technology are precious resources when they promote man's integral development, his whole development, for the benefit of all. However, the Church condemns some scientific methods, like the breeding of humans purely for research. Genetic research holds promise for human health, but also raises serious threats to society and its weakest member, the human embryo. There are the risks of eugenics, fooling around with the genes in the embryo. There's the danger of producing mutations that will harm individuals or the race, and the delicate problems raised by diagnosing genetic traits in adults. Scientists must respect the individual person even from the moment of conception. And I remember thinking years ago, a geologist wants to find out what kind of rock this is, and there are various tests that they use to see which it is. But if that rock is part of a sculpture, I'm quite sure that the Sculptors' Union could forbid it. You may not destroy the sculpture in order to find out what kind of rock it is.
So in other words, the Pieta made by Michelangelo, you can't take a chip
Hammer
off
a chip off it to see if it's really marble.
Yeah.
There's some things you may not do. You may not breed humans simply for research, just because it's a good thing to know. So the Church condemns certain methods of science, not science in itself. And finally, could there be life on other planets? There could. Some stars have planets like ours. However, life does not emerge automatically from the right physical conditions. On the other hand, we have no compelling reason to think that we are the universe's only intelligent beings. In fact, we know that we're not. There are the angels who don't inhabit the universe as we do, but we do know that we're not the only intelligent creatures God created. We cannot calculate the probability of life on other planets as we calculate probabilities in a card game, because we do not know all the steps by which life developed even on our own planet. The probability based on our experience is 0. We can only hope to recognize life on other planets if we find it. The Church has no position on this topic. To summarize then, God determines all the details of the whole physical universe at every moment, from the smallest elementary particle to the greatest galaxy. The business of science is to discover and describe patterns in these details. Scientists describe these patterns without referring to God. Analogously, the two-dimensional creatures on the card table can describe patterns among the cards without referring to the player. Thus, the patterns scientists discover neither require nor prevent belief in God. In fact, the whole question of whether or not the universe is governed by a transcendent, intelligent, and good being goes beyond the proper domain of the natural sciences. That question is what we talked about last week. Is the universe governed by someone outside, or is the universe all there is? We said then, rather briefly, that science couldn't answer that question. For some people, science fosters belief. A lady was telling me, a lady who's taking our course, who follows this kind of thing, she told me of an astrophysicist who believed in God. And she said, actually, something like 90% of them do. And I know the figures that Pope John Paul quoted in one of the documents that we quoted in here. Quite a lot, like 90% of scientists have in the past believed in God. For some people, science fosters belief. For others, it hinders belief. People evaluate evidence differently, as we said in the very first session. What convinces one does not convince another. Science and faith represent two different orders of knowledge, which are autonomous in their processes. However, they finally converge on the discovery of the integral reality which has its origin in God. So to go back to that thing I read at the beginning, two different descriptions of John Doe. The wife's description, his doctor's description, represent two different orders of knowledge, which are autonomous in their processes. The wife found out what her husband was like by living with him. The doctor found out by measuring temperature, weighing things, quite different ways. And the doctor did not have to refer to the wife to do his job, nor the wife to the doctor. However, they're both describing the same person. What place is there for science, then, in the Catholic faith? And that's what we call this, a place for science in the Catholic faith. Science adds nothing to God or his work, for God made not only the universe, but also science, scientists, and their ability to see patterns in his work.
That's very much what is said in the fourth common preface, preface of for ordinary time. Just that our ability to see
adds nothing.
Adds nothing to God, but gives us the means of seeing him.
Right. Human beings can know God without being scientists. And with Isaiah, even scientists must say to God, "It is you who have accomplished all we have done." However, through science, God can give us sound knowledge of existing things, that we might know the organization of the universe and the force of its elements, in the Book of Wisdom, which we read at the beginning. Thus, to believers, science presents new aspects of God, inviting us to even greater admiration for his greatness and prompting us to give him thanks for all his works. With Mary, then, scientists can say that they magnify God and his works. Mary said, "My soul magnifies the Lord."
I love a magnifying glass because it doesn't change what one is looking at. It just makes it appear bigger. But the card didn't get any bigger. My soul magnifies the Lord, but through Mary's eyes, we can see God more clearly.
With Mary, then, scientists can say that they magnify God and his works. In fact, as scientists, they have a certain responsibility to do so. If I were Francis of Assisi, this is a quotation from Pope John Paul. If I were Francis of Assisi, I would say, "O galaxies of the immense heavens, give praise to my Lord, for he is omnipotent and good. O atoms, O protons, O electrons, O bird songs, O blowing of the leaves and of the air, in the hands of man as in a prayer, sing out the hymn which returns to God."
Beautiful.
Now, there are a lot of footnotes in here, a lot of things we would have liked to expand on, which would have made it just too long and perhaps too difficult. For example, I'm looking at footnote 137. Pope John Paul said, "A scientist is a privileged witness of the plausibility of religion." The next paragraph, Father George Coyne said, "When I look at the universe, I think we are created in the image and likeness of God. In some sense, the whole universe is created in the image and likeness of God." He says the image of God was there in seminal form right from the beginning. Newton believed that what he called the most elegant order that he and Kepler had discovered in the solar system could not have been born without the design and power of an intelligent and powerful being who rules all things not as the soul of the world, but as the Lord of the universe. From blind metaphysical necessity that is absolutely identical always and everywhere, no variety in things can be born. The whole truth of things, including places and times, which we said scientists have to ignore in order to find patterns, could only have arisen from the ideas and the will of a necessarily existent being, that is, a being whose existence is not contingent on something else, but just because he is. And that is from Isaac Newton, quoted by Pope John Paul in an address to the Pontifical Academy of Sciences.
Just by being, we reflect God.
Also, footnote 140, as scientists, they have a certain responsibility to magnify God. The International Theological Commission said, Christians have the responsibility to locate the modern scientific understanding of the universe within the context of the theology of creation. That's what we've tried to do. That's why we call this talk A Place for Science in the Catholic Faith. And St. Thomas Aquinas said, it's evident that the opinion is false of those who asserts that it makes no difference to the truth of the faith whether one holds what one holds about creatures, as long as one thinks rightly about God. No, one has to think rightly about what he's created as well. Anyway, if you like this kind of thing, we encourage you to read all the footnotes. You can probably tell it's a subject which is very dear to my heart, because for me, science does foster belief.
The very word science comes from the Latin word knowledge.
Knowledge, to know, yeah. Now, in Appendix 1 on page 162, a reflection on science at the dawn of the third millennium. This is an address of Pope John Paul to the members of the Pontifical Academy of Sciences in 1996. It's rather small type because we wanted to get it fitted in. That goes on to page 164 and Appendix 2, an excerpt entitled Science and the Stewardship of Knowledge from a document by the International Theological Commission. I've left out paragraph 64 because it recapitulates Appendix 1, but all of these are available on the Vatican website. That goes on to page 165 and 66. So,
the more we know about anything,
yeah,
the more we know about God.
That's what Frank Sheed said. Each new thing known about God is a new reason for loving him. So what are we reading?
The reading for the next week, most appropriately then, is from the Book of Wisdom.
Where are you reading?
I'm sorry. Oops, we're getting onto the Psalms.
Yes.
Okay, but they're part of the wisdom literature.
Yes.
But the Psalms, we'll be looking at the Psalms for the next 4 or 5 weeks. So there's 150 Psalms, and this coming week we'll begin with Psalm 1 to Psalm 38. In the Bible this week, then, we'll see, and you do not need to read them just to read them, but pray them. Make it a prayer. Glorify God by looking at his creation through the eyes of the psalmist. And you will find everything you ever wanted to say to God somehow contained in the Psalms. For example, next week we will study divine revelation, what God has revealed.
Oh, God has revealed it, I think, actually, next week. Anyway, go on.
Yeah. What God has told us about himself and his plan for us. In the Psalms, we say, the revelation of your word sheds light, giving understanding to the simple. I love the Psalms. We read them in the divine office over and over and over again, the Psalms. They just keep coming through. But each one proclaims the glory of God and our relationship to Him. In the meantime, may Almighty God bless you, the Father, the Son, and the Holy Spirit.
Amen.